Okay, so we're going to look at some different type of word problems. These are actually considered work or rate problems. They are a little tricky to get used to, all right, but they're kind of neat, all right. So I've got two guys, Joe and Rick, and they are mowing yards. Now, we're going to assume that these yards that they're mowing are all the same size, and it's like a standard size lot or something. Joe, he's mowing 4 yards in 1 hour. All right, that's his rate. He can mow 4 per hour. Rick, he's able to do 3 yards per hour. All right. Now the question is, how long would it take them to mow 1 yard working together? That's the question. All right. What this is going to boil down to is finding some rate, some way to describe how well they work together, right? That's going to be the thing that we need to describe here. So let me go ahead and show you how one of these is done. Right. First thing I like to do is I like to put down just a couple of equations. So I'm going to say for Joe, I'll say 4 yards. He can do that in 1 hour. Seems pretty harmless. All right, got a little equation. And for Rick, I'll say he can do 3 yards in 1 hour. Right, this is just the truth. This is parts of this is something that the problem told me. Now, given these two little pieces of information, I can figure out what they can do together. Okay, I can find their together rate. And the reason that I'm able to figure that out is because the time slot right here. That's the key. Because the time is both 1 hour, the time slot is the same. That's what makes this problem kind of doable. All right. Well, if he can do 4 yards per hour and he can do 3 yards per hour, then together they can do 7 yards in 1 hour. Hopefully that makes good sense. I'm combining these two equations, I'm adding them, but I'm keeping the time part the same because I'm assuming it's the same 1 hour time slot here. Right. Together they can do 7 yards in 1 hour. That's pretty powerful. Now, what the question wants us to do is find out how long it would take them to just mow 1 yard working together. What you do, this right here, this equation will allow you to solve for all sorts of stuff. But what I'm going to do is I'm going to take this equation, and since I want 1 yard, like that's the part that I'm interested in, I'm just going to take this equation and divide by 7. And that's what you do. So I do 1 divided by 7, and that's going to be my answer. In 1/7 of an hour, they can do 1 yard if they were working together. So that's my answer. If you wanted to make this into terms of minutes, you could do 1/7 and multiply that by 60. And there you go. This means it takes them 8.5 minutes. Okay, 8.57 minutes if they were working together. And hopefully that makes sense because, if Joe is mowing 4 yards in 1 hour, that means he's doing 1 yard every 15 minutes just by himself. Okay, and so if they were working together, it should be less than this 15 minutes. All right, let's do one more. This one, the time slot is not going to be the same. Like here, 1 hour, 1 hour. When you check this one out, the time part is different. So we're actually going to have to force the time part to be the same. All right, I'm cleaning a room, and I guess it's a standard size room. It takes me 30 minutes to do it, but my fast brother, he can do it in 20 minutes. All right, I don't know, he's way faster, better cleaner. He's not as distracted as I am, I guess. So the question is, how long would it take us if we work together on it? Now that's assuming we don't fight and bicker. How long would it take us to clean this room if we were just doing it at the same rate? We weren't stepping on each other's toes or anything like that. So let me set up those equations again. I like to do that. For me, it takes 30 minutes to do one job. All right, you could put one room if you wanted to. For my brother, it takes him 20 minutes to do the same job. Now, what we want to do is we always want to focus on getting this time portion the same. So what I'm going to do is I'm going to scale up these equations until the time part's the same. For this one, it's not that bad. If I can do one job in 30 minutes, then I can do 2 jobs in 60 minutes. All right, 2 jobs in 60 minutes. And if my brother can do 1 job in 20 minutes, then in 60 minutes, he can do 3 jobs. Okay. The key here has to do with finding the least common multiple for these two parts. What you want to do is you want to find the something that they have in common, some multiple where they meet up, and you're just going to multiply each equation by whatever it needs to be multiplied by so that you get that LCM of 60. So what I did was I took that top equation and times it by 2, and I took the bottom equation and times it by 3. That's how I got these numbers here. Okay. It's actually a lot like adding fractions, like if you were doing 1/2 and 1/3. Like if you wanted to add these, you'd have to make the denominators the same. And so you would multiply this fraction by 3/3 and that fraction by 2/2 to kind of scale them up. Okay, well, now that the time portion is the same here, we're able to figure out our together rate. Okay, we can find out how fast we can do stuff together. All right, it just so happens that it was 1 hour. Again, this doesn't always have to be the 1 hour mark. But in 60 minutes, all right, if I'm doing 2 jobs and he's doing 3, well, that means that we're doing 5 collectively in 60 minutes. All right, and now we can do something to this equation to answer the question. We want 1 job, so I'm going to take this equation and I'm going to divide by 5, so that way I get 1 job on it. And then 60 divided by 5 is 12 minutes. Okay, and that would be the answer to this question. Okay, so the general scheme, the thing that you want to shoot for, is figuring out how to get these time slots to be the same. Okay, we'll do one more here in the next video.